when we're working with logarithms, we're going to have to use bases other than 10. So let's take a minute to think about powers other than powers of 10. So what do I mean by that? So you remember this is from Unit 2, so go back and remind yourself of that unit if you don't remember. So they were working in powers of 10. So for example, if we had 10 to the power 3, then 10 is the base, 3 is the exponent, and the whole thing is the power. And similarly, let's imagine we have 2 to the power 3. Then just the same, this 2 here is the base. Let's make this nice and... excuse me. So 2 is the base. 3 is the exponent, written up small at the top there. And again, this whole thing we could say is a power. Alright, and all these same rules apply, and I'm going to come to them in a minute. Let's just remind ourselves about this. So if we have 10 to the power 3, then that's the same as multiplying 10 by 10 by 10. And just the same, so that's 1000. And 2 to the power 3, just the same, it's 2 times 2 times 2, so that's 8. And we can do just the same thing. This base doesn't have to be a whole number, it could be a fraction. So if we have, let's say, 2/3 to the power 4, then that's 2/3 times 2/3 times 2/3 times 2/3, which is, if you multiply 2 times 2 times 2 times 2 times 2, that's 16 over 3 times 3 times 3 times 3, that is 81. Okay, so I think that's all fairly self-explanatory. So whenever you have to multiply the base by itself as many times as the exponent. So if we had 2 to the power 17, then we had to go 2 by 2 by 2 by 2, etc. 17 times. Alright, so let's just work through these rules quickly. So with some actual numbers, so we've got a to the power m times a to the power n. That's the same as saying a to the power m plus n. Okay, so that would be, for example, if we have 2 to the power 2 times 2 to the power 3, then that's the same as saying 2 to the power 2 plus 3 is 2 to the power 5. And if we expand that out, that's saying 2 times 2, so that's this one. And then we've got times 2 times 2 times 2, so that's this one. So that's the same as saying 2 times itself 5 times, and 2, which is 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so these two things are equivalent. So just the same. So now let's work through the next one. How about if we've got a to the power m, all raised to the power n. So let's imagine we've got 3 squared, and that whole thing is squared. So that's the same as saying, that's 3 squared times 3 squared, which is 3 times 3 times 3 times 3, which is 81. 3 times 3 is 9, times 3 is 27, times 3 is 81, which is just the same as saying 3 to the power 2 times 2, 3 to the 4. So you see this all is the same. Right, how about if we've got, let's think of an example. Let's say with our 3 to the 3 divided by 3 to the power 2. So that's the same as saying 3 to the power 3 minus 2, which is 3 to the power 1, which is 3. So let's make this into a fraction. So that's 3 to the power 3 over 3 to the power 2. 3 times 3 times 3 over. Then we can cancel these out, which leaves us with 3. And finally, a to the minus 1 is the same as saying 1 over a. I don't think I have to talk about that too much. Alright, so we don't have to have 10 as our base, so that's what we're using in scientific notation, but we can use another number if we want. And these same rules that we're familiar with from base 10 still apply, whatever the value of the base is.